Hello everyone, very good morning to all the students who have joined this session on digital communication, and we'll begin with a new topic of information theory and coding from this lecture. I hope my voice is properly audible. Is my voice properly audible?
Yes, sir.
Thank you, Nirbhay.
Yes, sir.
Okay, thank you. Let me share my screen. Is the screen visible?
Yes, sir.
Okay. So we begin with our new topic of information theory. Now, this topic is very important because no matter what digital communication technology is being used or is being implemented, the performance of the system depends in a huge fashion on the information related technicalities. So it becomes very important for us to pay attention to this topic of information theory. Okay, so our the session and the upcoming lectures, they are arranged in this fashion, with a brief introduction to information theory, the relationship between uncertainty and information, mutual information, and entropy. Now I must specify at this point of time the terminology which is being used here, or a lot of terms which you will get exposed to in the upcoming lectures. It is not only related to digital communications per se. It has got its widest presence in lots of domain. For example, if I take image analysis, or if I take machine vision, image processing, etc., you will find a lot of usage of a parameter or a quantity called as entropy. So not only entropy is always referred to when it comes to digital communication or communication systems, but also in other domains. So a very good understanding, thorough understanding of these information related concepts would not only help you in communication systems technology, but also in other courses, so that you take care. Maybe if time will allow, I can share one or two images with different entropy levels, and maybe you can appreciate when the time will come for entropy. We'll discuss. So these are some stuff for making base for information. We all know this age is information age. The internet is there, mobile phones, streaming data, social network, all these things are there. So huge information flow is happening, and the information now has become the key to success. Can someone say the difference between data and information? Anyone like to give try? Data and information, what is the difference?
Sorry, sir. What?
The difference between data and information.
Data and information. Data is anything which we can code in binary.
Okay. And information?
Information is not sorted. It is random. Like there is no meaning to it.
No,
Okay.
I must differ on this.
Sir,
Data is yeah. Who wants to give try? Yes.
I think data is what is
existed and information is what we need.
Yes, yes. Yeah, towards that meaning itself. Data is what is the raw resource which is available in the name of data. For example, an Excel sheet. Take very simple example. An Excel sheet with student names as the entries and their performance in the internal assessment, right? This is a data, some statistics. The moment you bring out some meaningful values from it, we are calling it as information. Means I want to analyze if there is any pattern in the marks of the student, or if I want to bring out a piece of information regarding, say, the behavior of student performance with respect to maybe different months, maybe in festive months, etc. I mean, there can be different criteria. So information is the actual purpose for which we collect the data. There is no point in taking images from a camera and then keeping it stored in our hard disk. Till that point, it is a data. It is useful only when you extract information from it. Maybe you have collected data for bird identification. Thal Lake is there near to us, right? So bird enthusiasts, they go there and they capture images. So definitely a lot of information will be in there in mind, but if they want to perform some analysis of image, maybe classification of birds, etc., you need to extract information. So that is the crude difference between data and information. Is actually what we are looking for, right? What we want is information. Yes, we want data also, but at the end, some abstract values from that data results into information. So whenever you say that it is the age of internet and this and that, always say there is a huge amount of information flow rather than data flow, because information is what is useful to us. Anyhow, so behind all this information exchange and all this information is digital. We have lots of ones and zeros which are holding the information. So the present day status of information age is majorly an outcome of an article published by Claude E. Shannon in 1948. So Claude E. Shannon, he worked at the Bell Systems Technical Journal, Bell Laboratories, the mathematical theory of information theory. So it is like the sacred text when it comes to information theory, and you can see in 1948, very old. Now, when you look at information, it can be from different sources. It can be from telephone, radio, television, etc. I mean, a lot of information sources, thousands of information sources are there. But collectively, on a broader level, on a bird's eye view, if you look, what are the different concerns for information theory with that information available to you is to discover mathematical laws which are governing or controlling the system. Now these systems, they have been actually designed to communicate or manipulate information. So you want to analyze the mathematics of any given system on the basis of the communication or information flow which is happening, and also with the help of this information to set up quantitative measures of information, capacity of various systems to transmit. So here we are talking more in context of the digital communication systems capacity, how much information can be flown on a particular system. So that is the capacity, and then store and process. So first is, what are the mathematical, you can say, modeling of a given system based on the data being communicated, information being communicated, And how would you measure that data information? That is of the second concern. And system can be anything. A system can be wireless system can be a system which is generating images, a system can be something like a video recording device, it can be a sensed data. So that is the system dependent thing. Very important is the relationship between uncertainty and information. Now, to any of you, if you can say something about uncertainty. What is uncertainty? Anyone? Uncertainty. Technically speaking, someone said in the last question which I asked you, someone says random noise or something like that. Who was it? So who was that? Please participate.
Uncertainty is what that we cannot predict correctly.
Correctly. Okay, good. So uncertainty is any happening, any phenomena when we are not sure of the outcome of the process. Now, you may question why we are trying to establish a link between uncertainty and information. So that first paragraph will explain you why we are trying to look out for the relationship between uncertainty and information. Any information source produces an output that is random in nature. If that would not be the case, if source output had no randomness, means what? Output were known exactly before it actually happened, then there would not be any need or requirement to transmit it. Right? Suppose I'm looking for a information to be received by me. I want to know what is the temperature of, say, Shimla today. I want to know because I do not have that information. I cannot say anything about it. So I want that information. But what if I already have that information? Then definitely I would not require someone to send that data to me. So this process of sending and receiving messages through communication would be required only when there is uncertainty, when there is unavailability. Right? And this uncertainty is resulting because of the randomness. If I know, a hypothetical situation, just consider if I know today is 21st September, tomorrow is 22nd. So every year 22nd September, it is always 24 degrees centigrade in Shimla. A hypothetical situation. Okay. So I would never ask anyone that what will be the temperature on 22nd September, because I know it is always, every year it is 24 degrees centigrade. But that is not the case in real life, right? It is random in nature. It can be 25, it can be 24, it can be 28, it can be 19. Nobody knows. So that creates the utility of the information which will be required to be transmitted to me. I want that information because I cannot say anything about it. So that is the uncertainty. Because of the uncertainty in the value of the temperature on a particular date, I need that information, right? And when you need the information is created. That is the relationship between uncertainty and information. अगर सब कुछ पहले से पता है, then we know everything. We don't want any communication. When there is no communication, there is no concept of information theory, right? So randomness is inherent in the physical processes and information processes, and that is leading to information. Now, with this mindset of the relationship between uncertainty and information, You look at information source as analog or discrete. So analog, I mean, information source like speech, temperature fluctuations. Discrete, for example, when someone is typing a sequence of letter in email. If you're collecting digital data, that is also a discrete form. So with this context, now let me present this situation to all of you. There are three statements written here, A, B, C. Please read these statements. Nirbhay, can you read A, B, C?
Yes, sir.
Please read one by one, A, B, C.
A. Two, two, two more. Tomorrow the sun will set in west. B. You will receive an email between 1 to 2 p.m. C. It will snow in Gandhinagar next winter.
So, Nirbhay, what excites you amongst these three sentences? What is exciting you?
So the sentence will not true because sun will never set in west, and you मतलब this sentence are.
नहीं ये तो सही है ना. The sun will set in west. West में तो
Yes,
set.
sorry sir. I
देखो सेंटेंस तीनों करेक्ट है ना, वो गलत
Yes,
नहीं है. लेकिन when you read these three sentences, आपको सबसे ज्यादा यानी इंटरेस्ट किस में आ रहा है, क्या पढ़ के आ रहा है?
sentence C में it will
Yes,
snow in Gandhinagar next winter.
yes, है ना. और ऐसा क्यों आ रहा है इंटरेस्ट? क्योंकि आपको पता है कि गांधीनगर में तो कभी स्नो होता ही नहीं है. There is never a snowfall, and it is very hard to believe that there will be snowfall in Gandhinagar. Now, the similar attention you are not paying to the first sentence. It is a universal truth. The sun sets in west, the sun rises in east. है ना? सब पता है मेरे को, मत बताओ ऐसा. That is the notion in mind, right? You believe इसमें क्या बताया है ना, इसमें क्या है, ये तो सबको पता है. सबको पता है मतलब ये इंफॉर्मेशन आपके पास ऑलरेडी है. B sentence, you will receive an email between 1 to 2 p.m. इसमें कुछ इंफॉर्मेशन है. Provided कि email is intended for a simple purpose. Yes, daily emails come. एक और आ जाएगा 1 to 2 p.m. में, no problem. But if I change this sentence like you will receive an email between 1 to p.m. regarding your passing of exam, then it attracts attention, because email related to passing an exam between 1 to p.m. not comes daily, right? It comes rarely, and only when marks are announced. So now you link up these three sentences with the probability of occurrence. If you look at a sentence, the probability of occurrence is 1, believing that there will not be any, what is that, doomsday or what, then what we call that, final judgment day or something like that. Sun will always set in west. So highest probability, it will definitely occur. B will have certain probability, right? Because email will not always come. Whereas in C, very rare. The rare means rare of the rarest, least probability. So you are paying more attention to C. So because of this probability variation in these three sentences, you believe you have a very high information for sentence C. Assuming that sentence C, your friend is not saying to you. Suppose some government agency is saying to you, so you believe यार ये तो एक अच्छा agency से आया है, so it's very hard to believe. So you take it seriously, right? You consider more information in that sentence C. So it is related to what? Probability. A, B, C all carry different amount of information. A carries hardly any information, everybody knows. B carries, and C carries a lot of information. I definitely believe everybody would have read it twice or thrice. What is written here? Is it a joke? So this is how the amount of information is contained in a sentence. Okay. Anyone has any query, any doubt? Please discuss. Okay, I believe it is clear to everyone. And so what is the takeaway from this 3-sentence analysis? Strong relationship exists between the probability of occurrence of events with the information they contain. Least probable, highest information. Highest probable, least information. Okay, the lesser the probability, higher the uncertainty, right? And higher the amount of information. So just one slide before this last slide, we have seen uncertainty and information. Uncertainty is dependent on the probability of occurrence, right? So this is the relationship. Also, the length of the message has nothing to do with the amount of information it conveys. Because you can see these 3 sentences, they are different, different size. Begin to conceptualize these through some mathematical formulation. Let's assume a discrete random variable capital X with possible outcomes small xi. That's how we denote it as a rule, where I can take index value as 1, 2, 3. So there are 3 possible outcomes. So this event of X with having values as x1, x2, x3, how much information is contained in this event capital X is represented as capital I xi. So the rule is, the formula is, information or the self information of the event capital X is log 1 over pxi, and if you take this pxi up, then a minus sign will come. Log 1 minus log pxi, log 1 is 0, so this becomes minus log of pxi. So the self information of the event X having xi value, it can be x1, it can be x2, it can be x3, is given by, the information is minus log probability. So note that high probability event convey less information and vice versa. High probability, highest value of probability can be 1, so minus log 1 is 0. Okay. Hence, for an event having probability 1, information is 0. Now, what is the unit of this information? The unit of information is actually dependent on this base of the logarithm, log px. So what base is there? It can be 2, it can be e. When the e is there, your unit is nats. E is 2.7 value. When the base is 2, it is bits. So yes, we are always dealing with a base 2 logarithm. Self information is non-negative. It can never be a negative value. Always non-negative value. Take one example. Consider an event in which a fair coin is tossed. Remember this word, fair coin. I will pose you to some question where I'll change this word in the later part. As of now, assume a sahi coin hai aapke paas, which is not biased coin, right? It's tossed and the binary output of 1 is taken for head if it comes head. The binary output 0 is taken if tails come. So it is a fair coin. So the probability of occurrence of values binary 1 or binary 0 is equal. 1 by 2, 0.5. So the information with regards to this event, tossing a coin, will be minus log pxi. So pxi is 0.5. So minus log 0.5 is 1 bit. Okay. Everyone? Am I audible?
Yes, sir. Audible.
Okay. So information content from each output of the source uses only 1 bit to represent. And that's what we are saying. Binary 1, how many bits we require to represent binary 1? Single bit. The same bit can be used to represent 0 also. So for this simple example, the simplest of the example, tossing a coin would require a 1 bit to transmit information. Now, further, if you make some changes to this event, assuming you have m successive outputs from this event, means m successive tossing of the coin to be statistically independent, means abhi jo toss kiya, it will not control the next tossing which you are going to do. The next toss and the current toss and the future tosses, they are all independent. There is no dependence, right? Assuming that situation, and if you have m successive tossings, right, m successive outputs, what it will generate? A block of m binary digits, every digit representing every event. So 2 to the power m possible m bit blocks, each of which is equally probable with probability 2 to the power minus m. Okay. अगर m total 3 events हैं and succession में हो रही हैं, so either it can happen 0 0 0, it can happen 0 1 1, it can happen 1 0 0, etc. So how many values it can take? 2 to the power 3. Total 8 possible combinations are there for m successive events. So when you have m successive events and you're observing the output with regards to this event, what is the information content? Ixi is minus log pxi, and here probability will be how much? 2 to the power minus m, because it is equiprobable. So minus log 2 to the power minus m is m bits. Yes, so m successive, we need m bits. So this is the information contained in this event. Are we good, students?
Yes.
Okay. Now, if your possible outcomes are say 0 0 0 1 1 0 1 1 from a memoryless source C, memoryless source C, statistically independent source. Okay, that is the memoryless source. You need not have to store the past outcomes in order to predict the next output. So since now these two bits are combined, so each one can occur with 0.5. So occurrence of 0 and 0, it will be the multiplication of individual probabilities. Similarly for 0 1 1 0 1 1, each are having 0 and 1, they are individual probability of occurrences 0.5. So 0.5 into 0.5, 0.5, because we are taking it as a group, right? So we multiply the probability. Hence, information content in this is 2 bits. 2 bits, 2 binary digits are there, 2 bits. You may wonder, sir, 0 0 0 1 liya, 2 bits to आएगा, but this scenario will change when the probability values will change. As of now, this is equiprobable. So now let's consider 2 discrete random variables, capital X and capital Y, with possible outcomes xi and yj. I is this and j is still m. Suppose we observe some output y equal to yj, and it is required to determine the amount of information This event provides about the event capital X equal to Xi. Means you have two events, two different random variables. One random variable you are observing and you are asked to find out what can be the value of X. When such is the analysis, we call it the case of mutual information. How occurrence of a particular value in capital Y can give you some information about the occurrence of the values of the capital X. So there is some mutual relationship between two different events. Earlier what we have seen is self information. This is mutual information. So anything, the word is mutual. What does it mean? There will be two entities, two parties. So here we have X and Y variables are there. Suppose now there will be two cases. Suppose the rule of the law says there is no dependence in the occurrence of event X and Y. So in that case, what we call X and Y are independent. Hence, occurrence of any value in the event capital Y, it provides no information about X equal to Xi. One can be like that. One situation can be like that. Another situation, yes, they are dependent. For example, we can think of a example like clouds are there and very high humidity is there, wind is not flowing. It is highly probable that it will rain. Okay, so if you consider say two variables, one is presence of cloud, yes or no, and presence of sufficient condition for rainfall to occur, maybe some humidity value, maybe. So if these two conditions satisfy the third event, which is the occurrence of rain, you can determine, you can say yes, it will rain, and you will be in a situation to say no, it will not rain, because suppose wind is blowing, the probability is there that wind will carry clouds, so the probability of occurrence of rainfall will reduce, right? So there is a relationship between different events in this example. So when X and Y, they are dependent, the occurrence of Y helps us to determine the occurrence of X. Okay, so any action, any happening, if you observe where two different events, they are related, so they are a case of mutual information. Are we good, students? This concept of mutual information. Yes or no? Chirag, can you listen? So I believe it is clear to everyone, and please do respond when your name is called. All students, please actively participate. So for mutual information, you have a concept of something we call as conditional probability. Okay, so this operator, this symbol, what you are seeing, a big, a vertical line, is actually conditional operator. P, probability of event X having Xi value given Y having Yj value. This is you have to understand like this. Probability of occurrence of event capital X as Xi, or we can say in more simple words, in simpler words, probability of a value Xi given value of Yj. So this will be given to you and you are supposed to find what is the probability of this value. So the concept of conditional probability is this Pxi given Yg divided by the probability of the occurrence of this individual value itself, Pxi. This is the formula. pxi given yj divided by pxi. This is the formula for conditional probability. Now, if we are dealing with, we are not dealing with simple probability, this is a case of a conditional probability, and we have seen this formula for conditional probability. What is the probability of occurrence of xi given yj? And also we are considering what is actual probability of pxi occurrence. We take the log, that will give the information which we call as mutual information. Mutual information in the phenomena where we are finding xi value given yj is given by this formula. Also, the same formula, if you replace the indices, this is xi yj. So I of information when the xi value is there given yj value has occurred is log pxi given yj divided by pxi is equal to log of pyj given xi divided by pyj. Given यहाँ पे क्या है yj and what probability you are finding pxi. You can interchange this given xi probability of yj. So I or the information xi given yj is equal to information with regards to yj given xi. This is the relationship. Okay. The information provided by the occurrence of y about x is identical to the information provided by the occurrence of event x about y. Are we good, students? Any doubt is there?
No, sir.
Okay. With this concept of probability, uncertainty, information, we move to the next topic, which is the channel. And the first simple case of a channel we are looking at is binary symmetric channel. This is the time now. We'll spend another 1 or 2 minutes and then wind up. So as you can see, channel means what? A medium which is taking the information over it from one end to another end. Okay, so this end is your transmitter end, this end is your receiver end. Data is being transmitted from Tx to Rx. Very simple. Where the data or the information will travel over channel. So binary symmetric channel is such a channel. Suppose you have 2 bits possible values which can be transmitted over the channel are 0 and 1. Transport 0 and 1 from Tx to Rx. Here also you can see what I transmit. If I receive that exactly that, I say I have received it without any error. But if I transmit 0 and I receive 1, that if that is happening with certain probability p as shown here, I say there is a probability of error. Okay, error can occur. I transmit 0, but out of 100 times it is possible that 10 times it is depicted as 1 in the receiver because of the noise presence. But 90 times I transmit 0, it is treated as 0 at the receiver side. So P is your probability of error, occurrence of error. Similarly, I transmit 1, occurrence of error is P. Probability of occurrence of error when I transmit 1 is again P, and it is depicted as 0 at the receiver. But if it is depicted correctly at the receiver, it is 1 minus P. 1 is total probability, error is P. So how much is the correct reception probability? 1 minus P. So this is a simple model for binary symmetric channel. Transports ones and zeros from Tx to Rx. It makes an error occasionally based on channel characteristics, environment characteristics. with the probability P. Let capital X and Y be the binary random variables that represent the input. So X is representing input and Y is representing output of this binary symmetric channel. Also assume input symbols. What are input symbols? 0 and 1. They are equally probably occurring. Their occurrence is equally likely. 4 times 0 occurred, so 4 times 1 is expected to occur. So we write something called as channel transition probabilities. What is channel transition probabilities? Here you can see an example of conditional probability. Probability of Y being 0 given X 0 means X transmit जो किया था that was 0. What is the probability you receive the 0? The probability of Y being 0 means the bit being received is treated as 0 given a 0 was transmitted. तो इस पे देखिए कितना है 1 minus P. Probability of treating a received bit as 0 while it was actually 1 while transmitting. 1 transmit किया और 0 depict किया, उसका probability कितना है P. So we have written this conditional probability as P. Similarly for P Y equal to 1 means at receiving side the probability of occurrence of 1 given 1 was transmitted. Correct reception. Okay, 1 transmitted, 1 received. How much is the probability? 1 minus P. And this is a error transmission. Actually 0 was transmitted, but 1 was treated at the receiving side. This is an error. And what is the error probability given here as per this binary symmetric channel? P. So this is this probability value we call as channel transition properties. Why this word channel transition is there? Channel is there first of all. Transition is happening between transmitter to receiver. The bit is being transmitted from transmitter to receiver. So there is a transition in the value of the bit. If there is no transition, it is a error-free communication. If there is a transition, it is an incorrect reception. Are we good, students, in this channel transition probabilities? Yes, everyone.
Oh, sir, there is one question, sir.
Please.
So, sir, this channel transition probability are fixed or it depends on channel or we fixed it?
The value of P can change, right? If there is, for example, if your channel is very noisy, right? So the probability of occurrence of error will be more, right? So P can have value say 0.4, 0.5 means whatever you transmit, say it is 0.5, right? P is 0.5. So 1 minus P, which is the correct transmission probability, will be again 0.5. It can be 0.6 also. A very noisy environment. You know that 10 bits if you transmit, no, 6 are going to be corrupted. And only 4 will be passing without any corruption. So it will, the value of P and vice versa 1 minus P will change as per the channel characteristics. It is not fixed. Okay, I hope I answered your query.
Yes, sir.
Anyone has any doubt, any query? I think we stop at this point, and you also start reading the content the same day, find time, because slowly and slowly a lot of mathematics will come into play during this progression of this particular topic. So the concepts related to uncertainty, probability, information content, the conditional probability, mutual information, and self-information. These, then the terms will increase. A lot of terms will come, so you should not get confused. So I hope you all are now aware what is self-information, what is mutual information. Self-information, occurrence of any event, what is the probability? It conveys that information. Mutual information, where two events are, two or more events, they are dependent on each other, right? So there is a condition. If this occurs, what is the probability that this will occur? So whenever such phenomena is there, whenever such conditional probability is there, we call it as a case of mutual information. Likewise, so we will dive deep into this information theory in the upcoming lecture. So if no further queries are there, I'm ending this session. Thank you, everyone.